Have you ever wondered what would happen if we gathered all the water on Earth and hurled it at the sun? It's a question that sparks the imagination, a cosmic what-if that leads us down a path of intriguing scientific exploration. Picture this: all the oceans, lakes, rivers, and even the moisture in the air coalesced into a giant water balloon and launched on a collision course with the star of our solar system. Would it be a spectacular cosmic event, a celestial belly flop, or something else entirely? Let's dive into the heart of this hypothetical scenario and explore the fascinating possibilities. Our journey begins by understanding the immense power of the sun, a celestial giant that dwarfs our planet in both size and energy output. Then, we'll delve into the logistical challenges of such an endeavor, examining the sheer volume of water we're dealing with and the immense distances involved. Prepare to be amazed by the sheer scale of this cosmic thought experiment as we unravel the mysteries of the sun and the potential consequences of our aquatic assault. Before we launch our watery projectile towards the sun, let's take a moment to appreciate the immense power of our nearest star. The sun, a giant ball of plasma, is powered by nuclear fusion reactions occurring deep within its core. Imagine the power of billions of nuclear bombs exploding every second. That's the sun's energy output. At its heart, hydrogen atoms are constantly fusing to form helium, releasing an unfathomable amount of energy in the process. This energy, in the form of light and heat, radiates outwards from the sun's core, taking millions of years to reach the surface. Once it reaches the surface, it bursts forth into space, bathing our solar system in its warmth. Understanding the sheer power of the sun is crucial to grasping the potential impact of our watery experiment. Now, let's return to our watery missile. Gathering all the Earth's water in one place would be a monumental task in itself. We're talking about 1.386 billion cubic kilometers of water, a volume difficult to comprehend. Even if we could somehow collect it, propelling this colossal water balloon towards the sun presents another set of challenges. The sun's gravitational pull is immense, and we'd need a rocket powerful enough to overcome Earth's gravity and then propel the water towards the sun. Such a rocket, even with today's technology, is beyond our capabilities. Additionally, the journey from Earth to the sun is vast, spanning millions of kilometers. Our water balloon would need to withstand the harsh conditions of space, including extreme temperatures and radiation, for the duration of its journey. As we can see, even launching a tiny fraction of Earth's water towards the sun presents a significant engineering and logistical challenge. Before we even consider launching all our water into space, we must confront the dire consequences for our planet. Water is the lifeblood of Earth, essential for all known forms of life. Removing it would be catastrophic. Without water, our planet would transform into a barren wasteland. Oceans would disappear, leaving behind vast, dry basins. Forests would wither and die, transforming the landscape into a desolate expanse. The air would become dry and unbreathable, making it impossible for humans and animals to survive. The consequences of removing Earth's water are too dire to contemplate. It's a stark reminder of the preciousness of this resource and the importance of preserving it. Section 5: Hosing down a star, an alternative approach. Let's imagine for a moment that we could overcome the logistical hurdles of collecting and launching Earth's water. Instead of a single projectile, what if we used a giant hose to spray the sun? This idea, while seemingly absurd, allows us to explore the interaction between water and the sun's immense heat more directly. As water droplets approach the sun, they would be met with unimaginable temperatures. Before even reaching the sun's surface, the water would vaporize, turning into steam. This steam in turn would be superheated to thousands of degrees, potentially breaking down into its constituent elements, hydrogen and oxygen. This scenario presents a fascinating thought experiment about the behavior of matter under extreme temperatures and the sun's ability to absorb and dissipate energy. Section 6: Stellar explosion or cosmic fizzle. Now the million-dollar question: would dousing the sun with Earth's water cause it to explode? The short answer is no. The sun is far too massive and its energy output too great for our watery assault to have any significant impact. To put things into perspective, the sun is about 333,000 times more massive than Earth. While water can extinguish a fire here on Earth, the sun isn't actually burning in the traditional sense. It's powered by nuclear fusion, a process that's unaffected by water. In fact, the sun already contains small amounts of water molecules, broken down into their constituent atoms within its atmosphere. Our watery addition would be but a drop in the bucket compared to the sun's immense scale. Section 7. Earth in the Aftermath, a Sunburnt World. While dousing the sun with water wouldn't cause it to explode, the consequences for Earth would still be significant. Remember all that water vapor and those hydrogen and oxygen atoms released as the water approached the sun? They wouldn't just disappear. Some of them might be drawn back towards the sun, adding fuel to its fusion reactions and potentially causing a temporary increase in solar activity. This increased activity could manifest as larger, more frequent solar flares and coronal mass ejections, which are bursts of charged particles from the sun's atmosphere. These eruptions could disrupt satellites, communication systems, and even power grids on Earth. So, while our watery attack wouldn't destroy the sun, it could still have unintended consequences for our planet. Section 8. A drop in the cosmic ocean, the sun-sized water balloon. Let's take our thought experiment to the extreme. Imagine, instead of just Earth's water, we somehow managed to gather a sun-sized ball of water. Now that's a cosmic water balloon. What would happen if we dropped this behemoth onto the sun? Surprisingly, even a sun-sized water balloon wouldn't cause the sun to explode. The water would be immediately vaporized and superheated, creating a massive cloud of plasma around the sun. This plasma cloud might temporarily dim the sun's light and heat, but ultimately it would be absorbed and dissipated by the sun's immense gravity and energy. However, the sheer scale of this event would undoubtedly have far-reaching consequences for the surrounding space environment. Section 9. Can we crack the sun? The idea of breaking apart the sun, while intriguing, is firmly in the realm of science fiction. The sun's gravitational pull is so strong that it would take an astronomical amount of energy to overcome it. Our sun-sized water balloon wouldn't even make a dent. To truly break apart the sun, we would need to overcome its gravitational binding energy, which is the energy required to separate its constituent particles to an infinite distance. This energy is so vast that it's beyond any technology we can currently imagine. So, while we might fantasize about splitting the sun, the reality is that it's a feat far beyond our current capabilities. The sun, with its immense gravity and energy, will continue to shine for billions of years to come, a testament to the awe-inspiring forces at play in our universe.